Morning guys, right, so this next video is now going to be looking at a concept called specific charge. Okay, now this is a concept that we don't touch on at GCSE at all, but actually it gives us a bit of a starting point to start talking about some of the ideas that you'll see both in A-level physics but also in A-level chemistry as well. You can see there I've had to prop up the paper using my Marvel pencil case. Okay, now we said in the last video that when we're talking about the subatomic particles, particularly your protons, electrons and neutrons, we said that we were able to look at their actual masses rather than their relative masses. So we said that the mass of a proton was 1.67 times 10 to the minus 27 kilograms. And the mass of an electron was 9.11 times 10 to the minus 31 kilograms, and the mass of a neutron was 1.67 times 10 to the minus 27 kilograms. Okay, so that's just a quick recap. Now, this idea of specific charge, what it is a comparison of the charge divided by the mass. This would give us a unit of coulombs per kilogram. Okay, notice the notation that we use here. We don't write coulombs over with the / kilograms. We use to the -1. It represents the same ideology. So we were going to look at, let's say, a hydrogen nuclei. We know that within the actual nucleus we've got one proton and one neutron. We know that this has a charge of 1.60 times 10 to the minus 19 coulombs, and this has no charge at all. So we were going to use these values along with the masses. It would say that our specific charge on the hydrogen nuclei would give us a numerical value of 9.58 times 10 to the 7 coulombs per kilogram. Now, don't be surprised for numbers to be very, very big. They are likely to be very, very big. The reason is because the nucleus is so small, but it has quite a lot of charge concentrated within it. Okay, so that's a very, very basic concept, fairly straightforward to follow. Just watch out for changes in the number of electrons. Remember, you've learnt about how an atom can ionize, but also as we start to expand this idea, start looking at radioactive decay, how numbers of nucleons can also change as well. All right, guys, as ever, any questions, any problems, email me.